already gave you that. Look what time it is. All right, give me questions about your homework. Boys. If you have trouble, you have. Okay. Somebody call out 14 to me. 7p. And then times 605 to 3 minus 2p. So here's the goal when you're doing exponential, and if you watch the video, you picked all this up, but the goal is to get it down to just one exponential piece, combining it any way you can, and then change it into a logarithm. All right, so in other words, here, how could I combine these? Well, we have to do what we call base manipulation, right, where we have to write them to have the same base. Do y'all remember doing this in Algebra 2? So what's the common base that I could use for 25 and 65? 5 to the what is 25? Second. And this 7p is still out here, times 5 to the 4, 3 minus 2p. So this becomes 5 to the 14p, 5 to the, and this multiplies and distributes through, 12 minus 8p. And what do you do when the base is the same and you multiply? You add the exponents, right? What is that noise? Where she worked before here? The vet's office with your aunt? Yeah, I was talking to her yesterday. She did go to our church for a little while. Yeah. I'm going to add these exponents together to keep this base the same. Meter. Wyatt? All right. I don't think I said. Okay. Oh, uh-oh. All right. Yes, because 25 squared. Yes, you could have. All right. 14p minus 8p would give me what, 6p? Negative 4 and 12 would give me 8. So now I can change it into a log. So log base 5 of 1 equals 6p plus 8.
I thought we were just solving for p.
How else are you going to solve for p?
Why do you make it? You keep the base because the base is the same.
Yeah.
You just keep that.
So now 16 equals -8.
You were supposed to use logs for some of these, y'all. If you couldn't get a base, so 6p equals -8, so p is -4/3. That's exactly right. Let me just, while I'm here, let me show you this, because this is an algebra, this is what we did in Algebra 2. We'll be making it a little bit harder in here, so just as a recap. If you get here where you have just one exponential piece equals a number, and you can't do a base manipulation, like say this equals 2, right? This one you can do a base manipulation, but let's say you couldn't, right? And you got it down to like this, you could change it to a logarithm. Okay? Remember how we do that. We do log. The base is the number that has the exponent hooked to it. So it's a base of 5 of 2 equals 6p plus 8. It always equals the exponent. This, I put on my calculator and get, remember I got to do that change of base. So I'd have to do log 2 over log 5. I'd get some decimal value and then I'd solve it for p. Y'all remember doing that now? Yeah. Give me the problem. Three minus. I'd make these have a base of 2. So 2 to the 3rd and 2 to the 5th. 27 minus 6x. I'm going to add 6x and subtract 15. So I'd get 12 equals. These were way too easy for y'all.
They really were, but I was going with it. I was like,
That's fine. 1/4 what? What was this? I would do a base of 2. Oh, yeah. Just in calculus this morning, it was a hot mess. It was a disaster. A hot mess. Medicine at lunch. It'll takes a little while to start working. Give me another one. Give me another one. Do the log stuff.
I'm tired of that.
It's okay. It's okay. I'll clean it up later.
Which one was it?
I know. What number was that we just did? 6. 6. That was 6. That was 12. Nope, it was 6.
It wasn't 6. We did 6 right before that.
Huh?
I need help with that. Alright, start.
Okay. We're not gonna solve log equations the way we did in algebra 2. If you remember, they're not gonna be that easy. Okay, so let me go over. 10 minutes, 15, 15. Give me 15. You want to hand it out? Here, Wyatt, hand it out. All right. When you get just one log in the equation, okay, what we can do is we can change the form over to an exponential form, an exponential equation. That way we can solve it. In other words, this becomes b to the what? Right? And so depending on what it looks like, that may benefit me. Let me show you an example. Always try to condense logs. Remember we talked about condensing and expanding? We always want to condense if we can. So for example, I'm trying to hurry because I told Sullivan 15 minutes. All my logs are here on the same side, right? And so I want to try to condense them down, thank you, so that it's just one logarithm so that I can solve it for b. This is not on yours. It's practice. All right, so how can you condense it, huh? Probably manna. Manna and Ruffle. I want to make sure I'm alive. Okay. Yes, that's exactly right. Because I'm adding logarithms to condense and multiply, right? So this would be log base 4. That is correct, Wyatt. How did y'all get that so fast? Y'all recognize difference of two squares? Backwards up, difference of two squares. If you didn't and you foiled it, that's okay. You come back to the same thing. You just had an extra step. What? So once we get it down to just one log on one side and a number value on the other side, I'm ready to change forms. So change the form. Squared. So now solve it. Why? Y'all have been doing crazy stuff for so long, but so I got 25 over 4 equals b squared. What's b equal? Plus or minus. There you go. Wait, go look and see if that chair's still outside that door. Right outside the store. What's the bottom leg broke on it? No, don't bring it back. Just take a picture. All right, here's what I want to do. Oh, it's a lot cooler out there. We need to hold that door open. Is it broke?
Yeah, it's right now. The dude's out there working on stuff. The whole, like, one of the legs is, like, broken.
Oh my god, like part of it.
Like, from here over.
That's not nice. Okay, so I need to condense, right? See, I got. I got logs, and then I just got this number over here, so I'm going to get it condensed down to just one log and see if I can't change the form. So tell me what I can do first. Compare. So I got log of. Oh, slow down, Speed Racer. Yeah. No. E to the fourth power. So this quickly becomes a calculator problem. What? I'm going to prop this door open because it's bless you.
Alright, I'll look for the I'll find each of the four. Yeah. But it's like a long number. It is, it's a decimal round it up.
Second LN, I think is what it is. No, what she? No, that doesn't work. It should be.
E is the button above LN. Above LN, so it's log LN. If you hit second LN, it comes up.
E to the fourth is 54 point.
LN?
LN.
It's LN.
Yeah.
It's above LN, or is it second LN?
And then when you add 15 and divide by 3.
We're working on 6 minutes. Oh, I see.
So if I've got 54.598 equals 3x minus 15, I can add 15 to both sides. Whoa. scenarios, there's logs and then there's some number by itself, right? But what if I don't have a number? What if I've just got a bunch of logs? Lots of logs. I want to eventually get to the point where I have the log of something equals the log of something, okay? Because when that happens, let's call this A and this B, then I can just drop them and say A equals B and solve from there, as long as these little bases are the same. So if I can make that happen some way, that's what I want to do. But notice the difference in this scenario and the other. In the other, there was this random number that was thrown in by itself, right? So if that's the case, I isolate down to just one log. But if I'm in this scenario where there's no number, what I want to do, excuse me, is get one log on either side and get them condensed down. So let me show you what I'm talking about, and then I'll be done. You couldn't change the x, it'd have to be like that from the beginning, but all of yours will be like that from the beginning. For example, notice how there's not a random, if this had plus 7, right? Then I'd go about it the way I've been doing it. But because it doesn't have that plus some number by itself or anything like that, what I want to do, I notice that all the bases are the same. I'm going to condense both sides down as much as I can. Okay, so on the left, what happens? We just multiply those two together, right? Equals now I can just drop the logs off. You don't like this? I was going to say, this is pretty easy. (16 and 4). No. Pause it. Give me an example. The only thing, like that. No. You could evaluate each of these individually, but I think you're saying, could you make this? Are you saying, could you do this? The what? I don't quite understand what you're saying. I see what you're saying. You're doing the backwards change of base is what you're doing. Right? This would be the same. All right, hold on. I have to think. I have to write. And this could be any number you want it to be. In your case, it's 8. Yes. All right, tell me what you think. Do I need to do any more? Y'all okay? I've already given it to you. Are y'all sure? Sullivan, how long has it been? I'm done. Yes. Tell me what I do. How do you know what scenario you're in? Yeah. The first one, why? I got a number by itself. So I'm going to condense these logs down. How do these condense? Divide. Why did I do that? It's because you're subtracting. That's exactly right. So now when I change forms, it's a little bit more difficult, right? Because I got 2 to the third equals this fraction. Wyatt, guess what I do? Butterfly. You really could, or you could just, so this is 8 equals 2w squared over w plus 3. How do I get w by itself? Multiply by, that's what I would do. Multiply both sides by w plus 3 to get rid of the fraction first. So now I've got 8 times w plus 3. And yes, now it becomes a simple solve like you're used to. I won't bore you with the